All right. Hi, everyone. My name is Dewar. I'm going to be a moderator today for today's session. And then towards the end, we're going to take some Q&A. So if you could please hold off until the end. So we're going to have two presenters today with Garrett in the red going first, and then followed by Tanner. So without further ado, floor is yours, Garrett.
Cool. Yeah, so this is Set DICOM on FHIR, how mapping can unlock DICOM metadata and images in FHIR workflows. If this isn't the session that you thought you were going to, you're not going to hurt my feelings if you leave. So my name is Garrett Rhodes. I'm a product strategist at Redox. Redox is an integration, a US-based integration platform, providing developers an API to consistently send and receive data, regardless of standard or source system with which they're exchanging data. I'm joined today by Tanner Engbretson, a senior software engineer who's sitting here in the front row. He'll be talking later and probably be the more interesting one. Our agenda today is I'll give a brief background on DICOM, provide an overview on DICOM workflows, why DICOM needs to be FHIRized, and then Tanner will go through a demo of Redox converting DICOM to FHIR, or maybe talk through some of the intricacies around the process in doing so. For those that were at any of my presentations last year, I always like to give just a quick FYI. I'm very much a Padawan. There are probably Jedi Masters as it relates to DICOM in this session. I know Gino's here, and so I'm a little bit nervous. Gino, feel free to correct me if I get anything wrong. My goal is really to explain the use cases stemming from DICOM, why translating it to FHIR is important, and then maybe show how Redox can help along the way if you decide, hey, this isn't really something I want to take on my own and would rather pay someone else to do. So yeah, I am the Anakin Skywalker. I have yet to grow out a rat tail, but maybe I will one day. So getting into some background around DICOM, the story around DICOM starts a long time ago in a galaxy of standards far, far away. And really by far, far away, I mean 1980. So DICOM was born out of an organization created by ACR, the American College of Radiology, and NEMA, the National Electrical Manufacturers Association, formed a standards committee for radiology. It wasn't then until 1985 that the committee published the first standard for image communication called ACR NEMA 300, very cool name. And then about 8 years and several iterations after that, DICOM v3 was released, and from here on out would be referred to as DICOM. That's what we know today. And then DICOM has gone through several minor iterations. Well, I guess it really depends on who you ask. Since 1993, in 2004, WADO was released, which is web access to DICOM. And then in 2013, DICOM Web was released, which is really just RESTful web services for DICOM. There are a lot of things to love about DICOM, even though the bullets are a little bit sparse around that side compared to the things to complain about. But the nice thing about DICOM is that there really is just one standard for all medical imaging, whereas for other forms of healthcare data, we have various different standards. Things to complain about is that it is quite complex. Although if you know the standard, spend a lot of time in the standard, you probably feel differently about that, or maybe you don't. There's quite obscure documentation, a lot of different pack systems and source systems that use various flavors or sub-flavors within DICOM or different message types within DICOM. So you have to know kind of all various different things about the standard itself. And then it's really just for imaging, which could be a good thing, but it also could be a bad thing if you need more than just imaging. So here we'll talk about why putting it into something like FHIR makes it more or easier to use across your potential use cases, which may pull in clinical data from things like HL7, legacy HL7v2 or CCDs, or administrative and financial data from standards like X12. Short plug, I'm also doing a talk on Friday morning about converting X12 to FHIR. So if you can kind of understand where Redox is focusing on, it's taking all the legacy standards and converting them to FHIR to give developers an easy way to bridge both the here, which is the reality of a very mixed bag of resources or mixed bag of data standards, and the hopefully now or in the future where FHIR is kind of all that really exists out there. So just to give kind of a quick overview on the medical imaging market and why it's so important, it's worth calling out that the market isn't small at all. The medical imaging market will experience a nearly 47% increase in the next 8 years, reaching upwards of $47 billion. That's US dollars. About a third of that is global revenue attributed to North America alone. Obviously, that extends as populations grow and medical guidelines change as well. So this growth could be attributed to several different factors, but at least in the US, there's an aging population, a rise in chronic disease, as well as a growing trend of preventative diagnostic practices that require extensive imaging to understand what's going on. Additionally, as things like skin cancer continue to rise, along with changes in dermatology guidelines, the demand for images increases for anyone serving that patient, whether it be providers or solutions that providers use in taking care of patients. And last but not least, the jury is still out on how effective and useful AI will be in healthcare, but it seems like a foregone conclusion that AI will surpass humans in the ability to analyze images for abnormalities. If that offended anyone in the audience, I take it back. But I think, that is probably a pretty useful application of AI. Speaking of AI, it was really hard to get a number of how many DICOM images are actually produced a year. I thought that would be like an interesting stat. So I just asked ChatGPT and it said billions. So hopefully that's interesting. So words are great and other data standards are full of words. But I think Dwight Schrute really summarizes it great, and that a picture is worth 1,000 words, or maybe even more, considering Dwight thinks words have no physical worth. Sorry, I'm getting over some allergies, so dealing with that. So there's a lot to be said about the benefits of images to patients, providers, and those that enable either of those two groups in providing care. And I think that's probably pretty obvious in that images are important. They tell a lot, potentially more than words. Everyone benefits when imaging is incorporated into medical records and medical decisions, and it's best not to leave DICOM behind as we propel forward into the future, realizing that DICOM is still very much used today, and how we can pull that into the future in a FHIR-based way is really what we at Redox and probably many others are thinking about. And so we'll talk about kind of some solutions we have around that, how we achieved that first cut at it, enabling DICOM in a FHIR-based world. So getting on to using the standard, just a high-level overview. Similar to other standards, DICOM has both query and push-based mechanisms, and similar to the world of other healthcare standards and EHRs, PACT systems or picture archiving. Oh man, I just forgot the C. Gino probably knows it. Oh, it is on my slide. Picture archiving and communication systems. Thank you. Are quite fragmented, leading to a world in which DICOM itself has quite a few different message types. So we'll talk about some of those message types here today. We won't cover all of them. Some of them are really what we took as a first pass in supporting the FHIR or supporting DICOM through FHIR. And last, but certainly not least, the standard is really only as good as the data within. And DICOM is similar to some other data standards in healthcare where there are quite a few inconsistencies around data availability due to how data does or does not get reconciled with things like the EHR or other systems. So while converting it to FHIR is great, you still have some data quality issues with how physicians use old systems and how those systems then communicate with others within the four walls of a hospital. So a quick aside on DICOM standards. We at Redox really focused on DICOM web enablement as opposed to DICOM. So DICOM web, you'll see often has the appended RS at the end of all of the message types to signify the RESTful state or RESTful enablement. DICOM web uses things like HTTP or HTTPS, whereas vanilla DICOM, or more standardly just DICOM, is still internet compatible and uses TCP as the transport mechanism. You'll also see the word WADO, and you'll see it on the next slide. That's an acronym for Web Access to DICOM Persistent Objects. So if we kind of put those two concepts together, you have WADO RS versus WADO URI, where that RS implies RESTful web services, and the URI implies the use of URL parameters on the source side. Both are useful. We at Redox, as we looked and unpacked the larger DICOM standard and then enabled it via FHIR, really focused on DICOM web, the DICOM web message types initially. So looking at some of those DICOM web message types, we're really focusing on, as I said, we were really focusing on the web service message types of DICOM for this presentation. The three big ones to know are Quito RS, Stow RS, and WADO RS. Quito RS enables you to query and search for DICOM series and objects using a patient ID, which then returns a unique identifier for further usage. Stow RS allows you to store DICOM instances to a PAX server. And then WADO RS allows you to retrieve specific instances and studies using the unique identifiers returned in a Quito RS call. So if we put some of that together, if you kind of think through the basic workflow of, hey, I have this patient, what studies or what DICOM images exist for that patient, and then retrieving those, the first piece of this uses that Quito RS call to search or read for potential DICOM images related to a patient. And so here at Redox, we utilize the FHIR imaging study resource to hold that call. And then in step 2, for those patients with imaging studies, you receive a URL endpoint telling you where the image is stored. And that utilizes the FHIR endpoint resource, which is nested within the imaging study resource itself. And then in step 3, to actually retrieve those images and retrieve those calls, you use the address returned in that endpoint resource to fetch the image itself. And that could be the raw DICOM file, or it could be metadata structured as FHIR, depending on your needs. Tanner?
Hi there, everyone. I'm Tanner, engineer at Redox. So what I want to do is kind of start by illustrating, like, why you might feel that interacting directly with DICOM adds a high enough degree of friction that you might actually want to reach for something new. And so I think the place to begin, if you're trying to make healthcare data useful, is to query for data. And so I set up PAX to use to illustrate for this example. And the code snippet I have here is some JavaScript code using an SDK to query that PAX for studies for a patient named Tanner that occurred on May 20th. And you can kind of look and see you've got 00100010 and 00080020, and if that's not immediately obvious to you that we're talking about name or dates, unfortunately things don't really get all that much better from here. And so if we're talking about integration broadly, a specific example from a specific SDK using a specific tech stack, it doesn't really tell you the state of anything, right? That's the experience that a handful of developers at best might be getting, right? So if you're talking about integration, you want to actually look at the Exchange format. And to do that, look at that. So this is the cfind query that was generated as a result of that SDK call. And if you don't recognize it, let me help you here. See, there's my name. But yeah, I mean, it's kind of funny, and I don't know. It's not meant to just slam on older technology. It is a binary format. Everybody knows it's a binary format. If you open up a PDF file in a text editor, it'll also look like junk to you too, right? But when I see it, I think of a quote from golf enthusiast Scott Van Pelt. He says, "To do business the way business is done," which is to say, if our goal is to enable the frictionless adoption of healthcare technology, then and to help people drive technical innovation, we need to rise to meet the innovators by offering them tools familiar to their domain. And the fact of the matter is that tools like technologies like HTTP and JSON are table stakes for technical innovation right now. So unreadable binary data over a raw TCP socket, calling that friction in 2023 would be generous, I think. So if you're seeing this and thinking, gosh, if only we could do this using HTTP with JSON or with REST semantics, well, be careful what you wish for, I guess. So we're going to fast forward to the year 2013. The Harlem Shake is going viral right now. So Roy Fielding's dissertation, which is the kind of seminal paper for RESTful APIs, was published 13 years ago at this point. And so as far as healthcare tech goes, being 13 years late to the party is pretty good. So at that point, we get QuidoRS, WaitORS, StoRS. And as Garrett mentioned, these are the RESTful APIs for communicating with the PACS. And this is taken directly from the QuidoRS documentation on the DICOM website. You can see some moderately sane looking routes and query parameters. It looks like using an API to some extent. Human readable words, that's an improvement to some extent. But let's look at the actual data when we're actually making these sort of calls. So I hope everyone can see that all right. But this is the result of making a QuidoRS query. I hope you can see we get our 0008, 0020, and our 0010. All those things they're back to the party, right? So this is kind of what I said before, where we got what we asked for. We wanted an HTTP interface, we wanted JSON, but we didn't get anything more than that. It's still conveying the exact same information in basically the same underlying format as before. And there's actually a pretty good reason for this, because the amount of information that can be conveyed within the DICOM standard is incredible. There's over 5,000 different possible data elements in the official DICOM registry, and that's before you get into anything that might be vendor specific or anything of that nature. So, I mean, how could you meaningfully change a format like that without doing, when it's so complex, without breaking it, right? Just the demographics fields alone are particularly incredible. It has everything from the military rank of the patient that you're dealing with, that would be 00101080, to what breed of dog the patient is, 00102292. So it's kind of easy to look at this and have a laugh at how dense it all is. And it kind of seems obvious that when we describe wanting to be able to query this with like a RESTful API, that it's not exactly what we had in mind. So if WaitORS, QuidoRS aren't exactly what we want, then what do we want? I think to answer that, we kind of have to look at what gets people so excited about FHIR in the first place. And it's not just the curly braces are more aesthetically pleasing than hexadecimal or carrots and pipes and all that, right? FHIR represents decades of accrued kind of collective knowledge and wisdom of navigating the minefield that is clinical data. And I know of some people that went off and made their own data models for healthcare data. We're out in the lobby handing out stickers and tote bags today if you'd like to talk to us. It's not easy. It's not easy at all. So this is really where the FHIR imaging study data model fits. It's not simply a matter of wanting modern things like HTTP or JSON. We also want to learn, we want to use something that's learned from data modeling pitfalls in the past. Like, for example, I would be thrilled if I never saw clinical data with time set in a local time zone implicitly ever again. Be great. So we want to be able to interact with imaging data in a way that fits into the relational model of FHIR, because that's how we want to deal with all healthcare data, right? We want to be able to query for it by patient or practitioner or location. And when I say those words, I mean the FHIR resources, not just the concepts. So functionally, what we're looking for is basically it amounts to a FHIR native index over the top of DICOM. So you want to have a format that's readable, writable, using the FHIR relational model, but and it doesn't try and re-implement 5,000 fields of possible DICOM data elements, and you want it to fit in your FHIR workflow. So Redox has implemented a imaging study query flow, and we've done that by handling imaging study queries, and then we proxy those out to the underlying packs in the form of a QUIDO call. And when we translate and aggregate the data, and we do URL rewrites so that any follow-up calls that to retrieve the actual underlying imaging data or further metadata can be done through the same API as the actual imaging study queries. So this flow shows the imaging study going through our engine, storing as logs, making it out to the external packs. Any follow-up actual image retrieval more or less follows the same flow, just not through our traditional engine logs. So that's the architecture as we've sort of built it. We hope to enable people to retrieve some DICOM images and serve their patients with it. Garrett, you want to jump back in here?
Yeah, I don't want to create.
Oh, feedback.
Yeah. Awesome. Yeah. So if it wasn't clear, our mission here at Redox is to make healthcare data useful. We do that through converting what is a mess of standards or what could be perceived as a mess of standards coming in from various source systems from a developer standpoint or those building healthcare technology, and converting that to a single FHIR-based API for developers to code and develop up to once, and then really bridge the gap between the here and the now and the future that we eventually wish to have, where everything is FHIR-based. So we're really excited about it. As Tanner said, we're out in the lobby. We have tote bags, pencils or pens, stickers, flyers. We'd love for everyone to come by and take some, because if you don't, we then have to bring it back to the US, and I'd rather fill my bag with other stuff instead of swag. So please come take it. But yeah, thanks for joining us. As I said, stop by our booth, hit us up on Wuvo, or you can email me directly at garrett@redoxengine.com, and happy integrating.
Hello. Thanks. Great presentation. We'll take a Q&A now. Any questions in the room?
Thanks for the talk. Did you implement structured reports as well?
Structured what now?
DICOM structured reports. I mean, with measurements.
No, we
No,
haven't done
you
that.
didn't. Okay. And you use Tank for the internal PEC server.
For testing, yes.
Yeah. Okay.
Any other questions?
Yeah, thank you. So how mature is the imaging study resource at this point? Because I feel like it's changed quite a bit over last versions.
Yeah, let me get to, am I off mute? I think I'm off mute. Oh, yeah, I put this thing in here so it didn't fall. Yeah, I think so. As with anything with FHIR, we want to make sure that we're good participants in the ecosystem and on the bleeding edge of things. So I think as the resources develop and become more mature, we stay up to date with those updates. I can't speak to imaging studies specifically on its maturity level relative to other resources. I'm sure there are other people in the room smarter on that front, but our philosophy at Redox is such that we hear developers come to us and say, hey, there are all these various data standards that we need data from. Historically, we put those into a proprietary data model. And now we've shifted all of that to a FHIR-based data model, or I guess a FHIR-based API. So we're not, we don't get too worked up about like adopting a FHIR resource in the early days of its maturity level, just because we want to help developers move towards FHIR sooner. As it gets more mature, we stay up to date with those changes. So that's kind of our philosophy. But yeah, I think it's a good point in that it's probably not at the highest maturity level right now.
In our 5, it's up to 4. So it's on track for limited.
Cool.
So I think the sort of FHIR side of this API that you present to clients makes a ton of sense. I'm wondering if you can speak a little bit to the complexities on the right-hand side of your diagram. So a couple of things that have come up as discussion points in, actually just go back to the, that one.
This
So,
one.
yeah, so like a couple of things that have come up in the Argonaut Imaging Access project have been things like, what do you do when there's multiple external packs within a health system? How do you sort of figure out how to fan out queries and where they go? What do you do if each of those underlying systems has different identifiers or different types of demographics that need to match? Kind of how do you abstract across that? And maybe that's just kind of the secret sauce here, but I'm wondering if you can speak to those complexities and how frequently the external PACS supports WAT-ORS in the first place versus having to sort of go down to the DIMC queries.
Yeah, so I would say a huge ask, and thanks for asking the question, a huge asterisk around a lot of this is we haven't done a whole lot. There's a whole lot of, a lot of the like DICOM ecosystem is legacy imaging vendors, and a lot of that still happens within the 4 walls of a health system. We're seeing increasing amounts of demand around pulling those out into more cloud-based solutions. Think like, your classic telehealth application that wants to pull these image files into, and then have a virtual based visit. So we're seeing demand for that. We still haven't done a whole lot of them. So I'll add a huge asterisk to that. In terms of fanning queries out, it's a tricky situation for us because we don't want to get into the position of saying one PAC server dominates another PAC server within the 4 walls of a health system. We have partnered with organizations like Verado, which have an enterprise master patient index. So if part of doing that process requires reconciling IDs to a single master ID, we can provide that service to our customers so that they don't have to go and buy their own EMPI and resolve patient identities to a single unique identifier. So I wouldn't say we have it figured out yet. I would also say we haven't really experienced it yet. So I think it's a good call out. I don't have a solution today, but I'm sure it's something we'll get to think about.
I'm excited, yeah.
Yeah. Or hopefully get to think about. Yeah.
Right.
So you mentioned a bunch of different types of DICOM tags, like a lot of patient demographic information. And I'm not super familiar with the imaging study resource, but can you speak to how often that is all that somebody wants? Do you often have to return a patient resource as well? And what kind of like formats? Are you just like returning those in a bundle or anything about that?
So we usually start our what we show here. We usually start from the perspective of making the query by demographics for the imaging study. So presumably you have a patient or something already in hand that you're then reaching out for an imaging study, and that does come with the bundled endpoint resources as well.
Any other questions? If not, we have one online. Tim Dean asked this question: have you done any FHIR integration that combines DICOM studies with PACS, with dictated reports and other textual interpretations of the DICOM imaging?
No.
Yeah, answer's no.
Sorry. No, we have not. But I think all the reports would be into like a diagnostic report resource or docref resource, depending on how that's structured, which I know is part of USCDI V3, I think. Yeah, is it down to V1 too? Yeah. So we have support for it in terms of actually seeing it out in the wild. As I said, as the giant asterisk here is we haven't done a whole lot of this. So if there's anyone in the audience that's super excited about this, we'd love to work with you.
Okay. There are no more questions. Thanks for joining our session. If you can give us some feedback at devdays.com/feedback. Thank you, everyone. Have a good day.
Thank you.